We haven't spent a lot of time over the last however many years of your education talking about statistics. Statistics is the study, analysis, and interpretation of data. And the honest truth is, no matter what career you go into, the likelihood is you will be studying, analyzing, and interpreting data. So we try to incorporate more statistics or statistics that might be important to you one day into the math classroom. So in analyzing data, we're going to start by talking of measures of central tendency. These indicate the middle of a set of data, and there are three types of measures of central tendency that we have already learned, and they were mean, median, and mode. Mean was just a fancy word for average, and you find an average by adding all your data values together and dividing by the number of data values you added together. The median represented the middle number in a set of data if the data was put in order from either least to greatest or greatest to least. Doesn't really matter. If you have an odd number of data, then you're going to have a middle number. But if you have an even number of data, then you have to find the two numbers in the middle and average them. The mode was the most frequently occurring value. And in order to have a mode, something has to occur more than once. You can have more than one mode. You could have one mode. It kind of depends on what value occurs most often. In problem 1, this frequency table shows the number of job offers received by each student within 2 months of graduating with a mathematics degree from a small college. What are the mean, median, and mode of the job offers per student? So, one of the things you have to look at is the fact that 2 students were offered 0 job offers. 2 students got 1 job offer. 4 students got 2 job offers. 5 students got 3 job offers, and 2 students got 4 job offers. So in order to find the mean or the average of the number of job offers, we're going to be adding 0 plus 0, plus 1 plus 1, plus 2 plus 2 plus 2 plus 2, plus 3 plus 3 plus 3 plus 3 plus 3, plus 4 plus 4. Now I realize I did not actually have to write down that many numbers, but you have to be careful because you have to know what you're actually dividing by. We're actually dividing by the number of students, which if you count up, 2 plus 2 plus 4 plus 5 plus 2 is going to be 15. The way the book does this instead is they say that there were 2 students with 0 job offers, 2 students with 1 job offer, 4 students with 2 job offers, 5 students with 3 job offers, and 2 students with 4 job offers, and then divided by 15. But either way that you do it, be careful about what they're asking you to find. They were very specific in this problem that they wanted you to find the mean of the job offers. Alright, so if I add all those numbers together, I'm going to find out that it's 33 job offers divided by the 15 students. Tells me it's about 2.2. So the average per student is 2.2 job offers, even though not everybody got 2 job offers. After you find the mean, the next thing we want to find is the median. Well, I'm going to go back up here because I actually wrote all the numbers here down in order from least to greatest. In order to find the mean, we want to find the middle number. So we just said that there were 33 job offers. But of those 33 job offers, I shouldn't say there were 33 job offers. Let me go back. In these numbers that I've written in order from least to greatest, we want to find the middle number. And since there are 15 numbers written down, there is going to be a number that's smack dab in the middle. The number that's going to be in the middle, such that the same number of data points are on either side of it, is going to be a 2, but it's going to be, let's see, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7. So the median must be 2. Usually what I do is I use my fingers on either end of the set of data and just kind of count backwards till my fingers end up on top of each other. Remember that this only works when there's an odd number of data. When there's an even number of data, you have to find the two numbers in the middle and then divide by 2. Now I want to find the frequency, the mode. The mode is the most frequently occurring value. So of all those values up there, the one that occurs most often is 3, because 3 occurs 5 times. 2 only occurs 4 times. Sometimes in a set of data, we get something called an outlier. An outlier is a value that is substantially different from the rest of the data set. When you arrange the data in order, the outliers will often occur at one of the ends, at either the left or the right-hand side of the set of data. Sometimes an outlier is an important part of the data. At other times it can be misleading because it affects measures of central tendency. Any time that we have an outlier that's going to significantly affect the mean of the data, we may want to discard it. But to learn more about that, you could enroll in the AP Statistics class. So let's look at a set of data. 56, 65, 73, 59, 98, 65, 59. Which one of these values is the outlier? Well, if we go put these in order from least to greatest, so I like to do this. 56, and then the next one is 59, and then the next one is 65, and then there's another 65. Oh, I missed another 59. See, that's what happens. All right, let's see. There were two 59s, two 65s, and then there was a 73 and a 98. What you can do is you can look at the difference between the numbers. So this goes up 3, this goes up none, this goes up 6, this goes up none, this goes up 8, and then this one goes up 25. Well, guess what the outlier is? When you want to calculate the mean of that data, that outlier is going to skew the data. It's going to make the data false. So you need to watch out for outliers. Sometimes we want to look at the range of a set of data. The range of a set of data is going to be the difference between the greatest and least values. When you order numbers from least to greatest, so for example, let's say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, just as a general set of data. You already know that the median, which is the middle number, divides the data into 2 halves. So here's my median. And you'll notice that there are 4 numbers to the right of it. There are 4 numbers to the left of it. Well, of those remaining numbers, there's a median of the first half of the data and a median of the second half of the data. And those medians have special names. They're called quartiles. So if you look at the data that's to the left of the red dashed line, these both are in the middle. We would find out that the median of that half of the data is 2.5. We call that quartile 1. To the right of the red dashed line, we would find out that the median of those two numbers is going to be 7.5. We call that quartile 3. The reason that's called quartile 1 and quartile 3 is because the median of the entire set of data would be called quartile 2. And what we'll learn to do in the next video is how to create something called a box and whisker plot, which is a way of displaying on the graphing calculator, nonetheless, these different quartiles and the maximum and minimum values. In problem 3, I have given you the average monthly water temperatures for St. Petersburg, Florida and Key West, Florida for each month of the year, so starting in January and ending in December. So there are 12 sets of data for each location. What I'd like to do is I'd like to compare the 12-month water temperatures for both of these locations. In order to do this, I'm going to look at these measures of central tendency. So I want to find the mean for each location. Well, to find the mean for St. Petersburg, you're going to add those 12 numbers together and divide by 12. When you add them all together, you should get 900. And 900 divided by 12 is 75. So for the year, the average water temperature is 75. The mean for Key West, Florida, if you add all 12 of these numbers together, you should get 949. And 949 divided by 12 is 79.1 approximately. So in Key West, Florida, the average monthly water temperature is higher, which kind of makes sense because Key West is south of St. Petersburg. Well, now let's go and find the median. Well, no, let's go find the mode first because that's going to be a little bit easier. Let's go find the mode for St. Petersburg, Florida. Is there a most frequently occurring number? Well, I see that 64 pops up twice. I see that 84 pops up twice, and I see that 86 pops up twice. So this particular set of data has 3 modes. Now if I go look at Key West, Florida, I see, 82 pops up twice, and 87 pops up twice. So the modes are 82 and 87. To go find the median, and then to go find these things called the quartiles, I'm going to have to go write each of these sets of data in order from least to greatest. So let's start with St. Pete. 62, and then there's 2 64s, and then there's a 68, and then a 70, 74, 78, 80, 2 84s, and then 2 86s. So since there are 12 sets of data, I'm going to need to find the 2 middle numbers in order to find the median. So the 2 middle numbers, if I count from each end into the middle, I'm going to find out are 74 and 78. And so 74 plus 78 divided by 2 is going to be 76. So that's the median of the set of data. But what if I want to find the median of the top half of the data and the median of the bottom half of the data? If I draw a line down the center such that there are 6 numbers on the left and 6 numbers on the right, I'm going to find out that the average of these 2 numbers is going to give me the first quartile. 64 plus 68 divided by 2 is going to be 66, so that's the value for quartile 1. And then for the top half of the data, these 2 are in the middle. Well, when you add them and divide by 2, you're just going to get 84. So that's quartile 3. Remember that this is quartile 2. The other thing that we're going to have to find before we learn how to make these box and whisker displays is something called the interquartile range. And the interquartile range is Q3 minus Q1. So 84 minus 66 is 18. Well, now I got to go back and I'm going to do the same thing for Key West, Florida. So for Key West, it's going to be 69, and then there's a 70, and then a 72, a 75, a 76, 78, two 82s, an 85, an 86, and two 87s. Alright, so now I'm going to find the median of this set of data. The median of this set of data, the two numbers in the middle are 78 and 82. So the average is going to be 80. That's the median. And then I'm going to divide this down the center, and I'm going to find the median of the bottom half, which is quartile 1. 72 plus 75 divided by 2 is going to be 73.5, and that's quartile 1. And then the median of the top half of the data, quartile 3, is going to be 85 plus 86 divided by 2, which is going to be 85.5. And then the interquartile range is going to be Q3 minus Q1, which is going to be 12. And that is all that I'm going to put into part 1. When we go to part 2, I will refer back to these numbers to show you how to make something called a box and whisker display, and I will explain as well how to do it on your graphing calculator.